I am Dr. K Chennakesavulu from Department of Chemistry, Satyabhama University. Now I am going to give a lecture on structural theory in organic chemistry. In this topic, I am giving an introduction and introduction for bond fission and organic reactive intermediates and their stability and related name reactions. If you come to the chemical bond is a representation of two electrons. That means instead of writing two electrons, we are writing a single line which is indicating a chemical bond. If this chemical bond is broken, that means reactivity of that molecule, so we can indicate with these electrons, two electrons. Let us say this chemical bond will be broken in two ways. One is homolytic cleavage and heterolytic cleavage. Homolytic cleavage will give us the free radicals, heterolytic cleavage will give us the carbocations and carbanions. And these carbanions, carbocations and free radicals during the reaction, they will decide the product formation as well as their stability will decide the product yield. That means now it is a very important to know about the reactivity of these reactive intermediates and what are the factors affecting the stability of these intermediates. Now if you come to the factors, there are three factors which will influence the reactive intermediates. One is inductive effect, second one is the resonance, and third one is the hyperconjugation. If you come to the reactive intermediates, the carbocations, carbanions, free radicals, nitrines, carbenes and arynes, that is benzenes. These are the major organic reactive intermediates, and the inductive effect, resonance and hyperconjugation are the three factors which will influence the stability or reactivity of these reactive intermediates. After this, we are going to discuss some name reactions. The reagents. Reagents are three types. One is electrophilic reagents and nucleophilic reagents and free radicals. Electrophilic reagents means the reagents which will attract electrons, that is electrophilic reagents, and these electrophilic reagents will be having an vacant orbital. This is an two important characteristics of electrophile, that is they will be having a vacant orbital as well as they will be having an high affinity towards electrons. If you come to the nucleophile, a nucleophile will be having an electron pair on its thing, and they could able to donate the electron pair to the electrophiles. That is the nature of nucleophile. If you come to the free radicals are the very highly reactive intermediates which could able to, even if you see for example, if you see the chips packet will be very tasty because of the free radical present in the packet. That's what they will be storing the chips under inert atmosphere. That means whenever if you open the chips packet, that is a very reactive species which could able to react with our tongue and we can feel the taste. And even after opening the packet, even after 1 hour or 2 hours, if you see the taste, that will be different. That means the lifetime of the free radical will be decayed. That means there won't be any free radical in the packet and we may not feel it very taste. Bond polarization or electron displacement or electron redistribution or delocalization of electrons. If you come to the delocalization, localized means electrons will be staying in one place, that is within two atoms. Delocalization means electrons won't be stayed at a single place, they will be continuously they will be rotating from one place to another place. This is what delocalization. That means delocalization of electrons will decide the reactivity of organic compounds. If you come to the inductive effect, there are two types of inductive effects. One is plus I inductive effect or minus I inductive effect. The withdrawing groups, let us take chlorine, bromine, halogen atoms. If halogen atoms are present on carbon, so they could able to withdraw the electrons from organic compound. That means that will be a negative inductive effect. Let us see at the carbon 1 and carbon 2, carbon 3 and carbon 4. That means this negative inductive effect will be there up to 4th position of the carbon or 4th number of the carbon. This is the negative inductive effect. Similarly, a positive inductive effect or plus I effect, the compounds or functional groups which could able to donate the electrons to the carbon, that is a plus I inductive effect. Let us say alkyl groups or tertiary butyl group or ethyl or propyl or isopropyl. Similarly, here also the plus I effect will be up to a fourth number of the carbon which is given in this presentation. If we come to the applications of this inductive effect, there is an best example to explain this inductive effect, that is basicity of amines. These amines are three types. One is a primary amine, a secondary amine and tertiary amine. If you see the reactivity or basicity of these amines, secondary amines are the more basic when compared to tertiary and primary. This concept could be explained by inductive effect, because this is an amine is having an electron pair on the nitrogen. This electron pair could be donated to electrophilic compounds. If you see let us take a methyl amine, a primary amine, or isopropyl amine and tertiary butyl amine. If you see, the methyl amine will be having only one donating group. It is isopropyl is having 2 carbon atoms, and tertiary butyl is having 4 carbon atoms. That means if you see the electron donating nature of these alkyl groups is increasing towards 3 things. Within this, secondary amine is having a high basic nature because of the steric hindrance is a major factor here. That means here 2 factors are there. One is a geometrical factor as well as electronic factor. In secondary amine, steric hindrance is not dominating. In a tertiary amine, steric hindrance will be dominating. That means secondary amine, there is an electronic factor will be dominating. That is, electron donating capacity will be not depending on the alkyl group. In tertiary amine, there is a steric hindrance, and steric hindrance will dominate the electronic factor. The resonance is the next factor which will affect the reactive intermediates. We can take benzene as an best example for resonance. Benzene is having 6 electrons which could able to give this delocalization of these 6 electrons give an extra stability to the benzene ring. And second factor is, third factor is hyperconjugation. Hyperconjugation will be explained based on the Side-Jeff rule. That means dehydration of unsymmetrical alcohol will give us the highly substituted alkene. That is as a major substitute, major product. This could be explained by hyperconjugation. During an formation of an intermediate, so what will happen actually during the dehydration, the unsymmetrical olefin if you are taking, it will be forming an carbocation. In this carbocation, the tertiary butyl carbocation and secondary carbocation will be formed. The carbocation which is having a tertiary nature, that will be a major product in Side-Jeff rule. That is dehydration of alcohols. If you see, Side-Jeff, as per Side-Jeff rule, highly substituted alkene will be formed as a major product, and the another one will be as a minor product. In this lecture, we have discussed the bond fission and heterolytic cleavage, homolytic cleavage, the factors which is going to affect the stability and reactivity of reactive intermediates. In future lecture, we will be discussing the reactive intermediates, that is carbocation, carbanion, free radicals, arine and nitrines. Thank you.